Today we are going to study the chapter class 8, chapter 13, sound. So in our day-to-day lives, we hear so many sounds in our day-to-day lives. But what is sound? Basically, sound is a form of an energy that produces in us a sensation of hearing. And plays a very important role in our daily lives. It helps us to communicate with each other. We hear a wide variety of sounds in our surroundings. Sound is actually produced by a vibrating body. So for the production of sound, vibration is very, very important. And what is vibration? Vibration is the to and fro motion or back and forth motion of an object. For example, if you strike a school bell, it vibrates and it produces sound. If you pluck a stretched rubber band, it vibrates and it produces sound. If you beat a drum, its stretched membrane vibrates and produces a sound. And if you blow a bugle, the air column vibrates and then it produces sound. Now, this slide actually gives you the list of musical instruments and what is the vibrating part in these musical instruments. For example, you can see that in some instruments the vibrating part is stretched string, in some instruments it is stretched membrane, in some it is air column. So, veena, sitar, violin, they have a vibrating part which is producing sound as stretched string. Tabla, mridangam, drum has stretched membrane. Shehnai, flute and mouth organ has a vibrating part as air column. And there are some instruments which produce sound when they are beaten or struck, for example a bell, a manjira, jaltaran, etc. How is the sound produced by humans? Now, if humans, sound is produced by the voice box, that is also known as the larynx. So when we are speaking, so the sound is produced due to vibration of the vocal cords. It is the upper part of the windpipe. Two vocal cords are stretched across the voice box, leaving a narrow slit. So when the lungs force air through the slit, they vibrate and then they produce sound. So that is how the sound is produced in humans. Now, sound is actually considered as a mechanical waves, which means that it requires a medium to propagate. And note that production and propagation are two things. So production is due to vibration, but then how is the sound propagating? Propagating means how it is traveling. So it's a mechanical wave, it always requires a medium to propagate. It can go through solids, liquids and gases, and it cannot travel in vacuum because, as I've already said, it requires a medium. For example, sound travels through the solid thread of a CAN telephone. A whale listens to the reflected sound in water to locate its prey. And we are able to listen to sound because sound can also travel in air. Now, there is an experiment to show that sound needs a medium to travel. Now, you take a glass tumbler and make sure that it is dry and there is no moisture inside it. You place a cell phone in it. Ask your friend to give a ring on this cell phone from another cell. Now, listen to the ring carefully. Now, you surround the ring of the tumbler with your hands and put your mouth in the opening between your hands. Indicate to your friend to give a ring again and listen to the ring while sucking air from the tumbler. Now, what are you trying to create inside the tumbler? You are trying to create vacuum by sucking all the air out of the tumbler. You will notice that the sound will become fainter as you keep sucking the air. If you had been able to suck all the air in the tumbler, the sound would stop completely. Actually, sound needs a medium to travel. When air has been removed completely from the vessel, it is said that there is vacuum in the vessel and the sound cannot travel through vacuum. It requires a medium. How do we hear sound through our ears? Sound enters the ear through the ear canal. It makes the eardrum to vibrate. The eardrum sends the vibrations to the inner ear, and from there the signals go to the brain, and that is how we hear the sound. Now, there are certain characteristics which are associated with the sound wave. A few of them we are going to study, for example, amplitude, time period and the frequency of vibration. Firstly, to understand what is a vibration is a to and fro motion, it's a back and forth motion, and it is also known as an oscillatory motion. Now, here you can see a simple diagram of a pendulum which has its mean position as O and two extreme positions as A and B. And on the basis of this diagram, we are going to understand the characteristic properties of a sound wave. The maximum displacement of an oscillating body from its central position is called its amplitude. Now, in this specific example, OB or OA actually denote the amplitude. The motion of the pendulum from one extreme position to another extreme position and back is called oscillation. That is one oscillation. You can also start the position from the mean position. So if the pendulum goes from mean position to one extreme to another extreme and then comes back to that mean position again, it completes one oscillation, and the time taken to complete that one oscillation is called the time period. And the number of oscillations that are there in 1 second is called its frequency, and the unit of frequency is hertz. Loudness and pitch of a sound. The loudness of sound depends upon the amplitude of vibration. If the amplitude is less, then the sound is stable. If the amplitude is more, then the sound is loud. Very important to note that the unit of loudness is called decibel, also represented as dB. Pitch of the sound is actually determined through its frequency of vibration. If the frequency is less, then the pitch is less. For example, the sound of a drum or the sound of an adult. If the frequency is more, then the sound has high pitch, for example, the sound of a whistle or the sound of a baby, etc. We can classify the sounds as audible and inaudible. Audible sounds are the sounds which our human ear is actually designed to hear. So it has frequencies between 20 Hz to 20,000 Hz. And inaudible sounds are the sounds which cannot be heard by human ear, and it has frequencies either less than 20 Hz or they're more than 20,000 Hz. That is, it is not in between the range of 20 Hz to 20,000 Hz. Sounds whose frequencies are more than 20,000 Hz are known as ultrasonics, and below 20 Hz are infrasonics. Some animals like dogs can hear ultrasonic sounds, and bats can produce ultrasonic sounds through which they can also detect their prey. And then lastly, we have noise and musical sound. So unpleasant sounds that we hear in our day-to-day lives, for example, the sound of horns of the vehicles. So these are basically noise because these are unpleasant sounds to hear to, and it's produced by irregular vibrations. For example, in a regular classroom, if all the students start speaking together, then a noise is produced. Sounds produced by the horns of buses and trucks, also considered as noise. It may also lead to noise pollution. Musical sounds. Sound which is pleasing to the ears is called musical sound, and it is produced by regular vibrations. For example, the sounds which are produced by, let's say, a guitar, a musical instrument. Sound of a person singing a song. As I've already told you that noise can also lead to noise pollution. So the presence of excessive or unwanted sound in the environment is called noise pollution. What could be the causes of noise pollution? Noise pollution is caused by the sounds of vehicles, explosions, including bursting of crackers, machines, loudspeakers, etc. In the home, noise pollution is caused by television, radio, music systems at high volume. Some kitchen appliances, for example, mixers, dessert coolers, air conditioners, etc. What are the effects, harmful effects of sound? Noise pollution causes several health-related problems like lack of sleep, hypertension, high blood pressure, anxiety, etc. A person exposed to loud sound continuously may get temporary or permanent impairment of hearing. But what can we do, or what measures can we take to limit noise pollutions? Noise pollutions can be reduced by using silencers in the vehicles or in the industrial machines, home appliances, reducing the use of vehicle horns, running TV, radio and music systems at low volumes. Planting of trees along the roads and buildings also help to reduce noise pollution. I hope you have understood the chapter. Thank you.